All right, under the stratified random sampling, after we have decided on the total sample size n, we need to consider how we allocate the sample for each of the stratum. So n1, n2, all the way up to nl. We need to consider the three factors. They are the size of each of the stratum, capital NL, the variability of observation within stratum, sigma L square, and also the cost of obtaining the observation CL. So we may consider the NL, our sample size linked to NL, would be directly proportional to the capital NL, the population size of a particular stratum. This is quite trivial because the larger of the population size, we are likely to collect more of the sample. Secondly, the variability, which is sigma L square. Again, if within the stratum, with the variability or the sigma L square is large, then we tend to collect more of the data. So NL would be proportional, directly proportional to sigma L. Sometimes if sigma L is not known, then we can replace it with the estimate of SL from our sample. Thirdly, would be the cost of collecting the data from each single sampling unit. So the higher of the cost, we tend to collect fewer of the sample. So NL would be indirectly proportional to the square root of the cost. Okay. First of all, the optimal allocations, we call it OA. That is considering of the population size, variability, and also the cost. So in this case, the allocation of NL would be proportional to NL, capital NL, sigma L over square root of CL. In this case, if we're going to consider the sample size for a particular stratum, let's say N1, with N1 divided by the total sample size. So we are looking at the proportion of the sample size for N1 to the total sample size is directly related by the factor of the populations N1, variability sigma 1, out of the cost of C1 with respect or divided by the total of all the factors adding up together. Okay, so in this case, that after we have decided the total sample size, then we can multiply to a particular L stratum with the factors considered with respect to the total of all the factors adding up together to decide the allocations of it. Okay, for population proportion, we can replace sigma L by the square root of proportion PL multiplied to 1 minus PL. It's just the same thing. We just replace the sigma L by square root of P 1 minus P. Okay. Secondly, we call that the Lyman allocation, NA. Lyman allocations just consider the population size, NL, and the sigma L variabilities are being the factors. So we assume all of the costs of collecting the observation are equal for each of the stratum. Okay, so if that's the case, we can assume all the costs are the same. Then under the Lyman allocation, when we try to estimate the population mean, NL would be in the proportion of the populations multiplied to the variability as opposed to the total of all the factor. Okay, for population proportion, same thing. We replace sigma L by square root of P times 1 minus P. Okay, so the third allocations is the proportion allocations. So we even assume that all of the variabilities, sigma, are the same across all of the strata, as well as the cost. So if that's the case, we only consider the population size as the factor of determining the allocations of NL. Okay, so this is our, if we want to calculate the NL, this is with the populations of the L stratum with respect to the total population. In this case, we are multiplying our N times NL out of the total population N. The proportional allocations is very convenient. Sometimes if we don't know about the variabilities of the stratum, and if we don't know the cost of collecting the data, we could use proportional allocations. But even though sometimes we know that the stratum variance and the costs are not exactly equal, but people still wants to use proportional allocation because this is very easy. It just considered the factor of the population size. Okay. If under the proportional allocation, we can also refer the Y bar estimate under stratified random sampling is equals to all of the Y bar L adding up together weighted by the population size of a particular stratum. Under proportional allocations, it is the same as the little omega, the little w, because of the relationship of the proportional of the populations is the same as the proportion of the sample size. Okay, so it's a special case under proportional allocations that the capital WL is the same as the little WL, and also it is an unbiased estimator for the population mean. Let's consider example 4.9. In order to plan for the future housing policy, the Housing Department conducted a survey to estimate average household income over the urban area. And then they divide the population into 8 strata. And given each of the stratum populations, and we have the true variability sigma L, we can estimate the proportional allocations of my sample as well as the limit allocations. Okay, so we know that the total sample size is 501. Okay, if we are just doing the proportional allocations, then we allocate that 501 sample to each of the stratum. Okay, so 501 multiplied to the populations of stratum 1 out of the total populations. So we allocate this 501 at the same proportion of the population size of stratum 1 to the total. So that becomes 46. For stratum 2, again, 501 is my sample size, multiplied to the populations in stratum 2 with respect to the total population, etc. Okay, so we do that with my proportional allocations. Under limit allocations, it is also a special case because this is only consider the population size and the variabilities, but not the cost. Okay, so now we multiply the population to the variability sigma L. Okay, and the allocation would be 501, the total populations, total sample size, multiply to NL sigma L in stratum 1 with respect to the total of the summation of all of these stratas NL sigma L. So 1136135 divided by 1422, etc. Okay, so under limit allocations, the sample size for each of the strata would be considering the population size as well as the variability. Okay, so we can see under 2 different allocations, the samples collected from each of the stratum are different. And that will directly affect our estimate for the Y bar. Okay, so let's just focus on how we do under the proportional allocations. Okay, let's say if we follow the proportional allocations, we collect 46 data from stratum 1, 62 from stratum 2, etc. And then we have Y bar collected or calculated, and within this stratum we can calculate the variabilities, SL squared, the sample variance. Based on proportional allocations, we estimate Y bar is around 744.1614. Okay, and this is under proportional allocations. It's just like adding up all of the Y bar weighted by the population size or weighted by the sample size are the same under the proportional allocations, and the estimated variance is estimated around 80.4928. Okay. Since the costs under this question is not given, so we can't perform the optimal allocations. Okay. So let's try to compare the same estimate. The estimate for the variance under proportional allocation. If we use the true variance data, okay, so the estimate, the true variance is around 42.0366. But under the Lehman allocations, the variance could be revised or could be improved down to 41.5234. So this is a very good comparison between the proportional allocation and the Lehman allocations. It shows that under the Lehman allocations, we could achieve slightly smaller of the variance. With that smaller variance, we would say that the Lehman allocations is superior or better than the proportional allocations because of the sample size. The difference of the sample size is the factor in here. Why is the Lehman allocations is better than the proportional allocation in this case? If we look back to the raw data, we can see that N, the population size, they're quite different. So NL is served as a very good factor for our proportional allocations. But if we look at the variance, it's also quite different. It is quite different within each between each of the strata, and also they are not small. So sigma L is also served as a very good factor for us to determine the allocations of sample. So if sigma L is not insignificant, then we better make use of the Lehman allocations. We need to have that sigma L to be one of the factors for our allocations. Okay.